Let's talk about exponents and logarithms. All the content in this video applies to both SL and HL students. You most certainly already learned about exponents and their rules in middle school, but they are a part of the IB syllabus, so let's review them. Exponents are a way to notate repeated multiplication. Just like multiplication is repeated addition. This is all fairly simple, but there are certain rules that allow us to work with them. First off, the rule for negative exponents. Then, fractional powers, which are equivalent to roots. If we have a power of a product, we can just distribute it. We can also add exponents, like such. If we have a power to another power, we can simply write that as a product inside the exponent. And lastly, the 0th power of any number is always 1. Sometimes, we may see those rules written with additional ones, like this one. But it is really superfluous because we can see that is true with just our other rules. Often, we have equations involving exponents, like this one. This particular one is easy to solve using roots. But what if it was the other way around? Well, we can't just use the xth root, because the whole point is we don't know what x is. This is why we need to introduce logarithms. Logarithms are just the opposite of exponents. In this example, we can use a logarithm to isolate x by writing x is equal to log base a of b. The main idea with logarithms is to ask the question, what number do I need to raise the base to in order to get some other number? In mathematics, the most common logarithm is probably the natural logarithm, ln of x, which is the logarithm of base e, where e is Euler's number, the base of the natural exponential, which appears everywhere in calculus. In science, we often use the logarithm in base 10, for example with pH scales in chemistry. However, in the rest of the video, we will not look at logarithms in specific bases, but rather at logarithm rules with any arbitrary bases, a or b. Now, in the rules for exponents, the main idea was that we could turn a sum in the exponent into a product outside of the exponent, and a product inside the exponent into another exponent outside the exponent. Therefore, for logarithms, it is the opposite. Similar to the negative exponent rule, we also have that for logarithms. And the logarithm of 1 is 0 regardless of the base. We also have a way to turn exponents into products. And finally, the change of base rule does just what it says on the tin. It allows us to change the base of a logarithmic expression. All of those are on the formula sheet, but it is much better if you're familiar enough with them to not have to check every time. When we have equations involving exponentials, we use logarithms to solve them, and conversely, when we have equations involving logarithms, we can use exponents to solve them. This topic is really not that complicated conceptually, but it's just one of those things that need practice, because you need to be able to put all those rules together to solve equations and simplify expressions, which you'll need to do throughout all of the other topics in IB Math. We'll see you in the next video about counting principles or combinatorics.